Okay, so I have shared my screen. In the last two classes, we have seen multiplication, normal multiplication algorithm, as well as the optimized multiplication algorithm, right? So, is there any question or confusion in these two topics? Please let me know. Any confusion in these two topics, normal and optimized multiplication algorithm? No confusion. Okay, fine. So, we can move to the next topic, that is division. And for division, we have only one algorithm. This is the algorithm in here. So, uh, division for division, we need two numbers. One is dividend, another one is divisor. So, dividend is the number that is going to be divided by some other number. Then divisor is the number that is going to divide some other number. Okay, so this is dividend, this is divisor in here. If I say divide A by B, then A is dividend, B is divisor. And unlike the multiplication algorithm where we get only a product as the result, in here we get two results. One is quotient and another one is remainder. These are the two things we are going to get as the results in here in division algorithm. To store these two numbers, we need two register. To store these two as well, we need another register as well. Maybe in that register we can keep both quotient and remainder. We are going to see that in the algorithm. Okay, so today we are actually going to see some simulations. So this is the algorithm in here. We have to start, then initially we have to assign some values. After that, we have to do a shift left operation, then a subtraction operation, then a conditional operation. We have to check whether a is less than 0 or not. Then actually we are going to assign some values on Q0 and on A register. Then we are going to count if the number of bits is equal to the number of bits in dividend. Okay, then we are going to actually end after a few number of steps. Okay, so this is the algorithm. Now we have to understand what are these registers are. What is A, what is M, what is Q. Okay, so let me show you this algorithm first clearly. This A is a register which is initially 0. Q has the M has the divisor in it, the value of the divisor, and Q has the value of dividend. Okay, so if we are actually using three registers, how we are going to store four numbers? Like we have to store one number dividend in one register, divisor in another register, and A and Q. These are the two results. So what are the A and Q? Let me show you in this word file. So if we divide 10 by 3, we are going to get 10 as dividend. This is 10 in binary, 3 as divisor, 3 in binary. So if we divide 10 by 3, what we are going to get? Quotient will be 3, quotient that is denoted with Q, and the remainder is 1 that is denoted with A. And in here, A and Q are together a register, as you can see. The left half of a register is A, right half of this register is Q. Like the product register in previous example where it was product on the left half and multiplier on the right half. Now in this example, we are going to use this AQ register. We are going to say or denote this register as AQ register. In this register, we are going to say on the left half it is A, on the right half it is Q. Okay, so it is AQ register. Okay, and if you can see the results in here at the top, Q is for quotient, but initially in the Q register we are going to have our dividend. So after this steps, number of steps that we need to complete the division algorithm, this dividend in Q will be replaced with the result Q quotient. Okay, and in A it was initially 0. In A register it will be initially 0. like this, then it will be replaced with the remainder. So AQ is the remainder quotient register that has A on left, Q on right. Initially A is 0 and the value of Q is initially the dividend. And divisor is another stored in another register, that is M. So actually we have three registers, A, Q, together A register. Okay, actually we have two registers, A, Q together A register, and M is another register. Okay, so is it clear? Initial phase, please respond. Is it clear or not? And in the counter, we are going to count the number of steps. For 4 bits, we are going to take 4 steps to complete the division algorithm. Okay, so this is the algorithm in here. Now we are going to see a simulation based on that. Now what we need, uh, if we look at the algorithm in here, let me zoom in. Okay, if we look at the algorithm, we have to shift left. We have nothing problem in shifting left. We know about the shift left. We know about the carries as well, that we have to push the carries uh, whenever we are going to shift left or right. So we know about these things. But how come we are going to do this operation? A is equal to A minus M. Remember, everything is going to be done with addition only. So we are going to perform this subtraction with addition only as well. How? A is equal to A plus minus M. We have the value M. We can use 2's complement to get minus M, and we can then perform A is equal to A plus minus M. Is it clear how we are going to perform this operation in here? Please respond. To have that minus M, we need this 2's complement. Now we have M. Initially M is divisor, and in this algorithm divisor is 3. So M has value 3. We need to find minus M. Why? Because we are going to perform A minus M as A is equal to A plus M. So what will be minus M? Use 2's complement. So first 1's complement of M, which is every 0 as 1, every 1 as 0. So every 0 and 1 represented as vice versa. 0s as 1, 1s as 0s. Then this is 1's complement. We have to add another 1 to get the 2's complement, which is minus M. Remember, if we use 2's complement on any number, we get the opposite number. If it is positive, it will become negative. Negative will become positive. This is it. So this is 2's complement of this M. Okay, so this is minus M. Whenever we are going to add A with minus M, we are going to use this value. So initially we have a 0 in A, like the algorithm saying 0 in A, dividend in Q, divisor in M. And remember, A and Q are together a register, not separate from each other. This is two part of a single register. In left, it has A, and on right, it has Q. Okay. So this is it. Now, what we are going to do, we are going to go to the step 1. In step 1, after starting assigning all the initial values, we have to shift left AQ. Shift left the register AQ. So, sorry. So we are going to shift left AQ. Remember, A was this 4 zeros, right? A was this 4 zeros, and Q was 1010, the dividend. Like the algorithm says, Q should be dividend. So it was the initial step. Now we have to shift left. How can we shift left? Can you guys please let me know? Somebody from you.
Adding a 0 from right.
Normally we add a 0 at the right in this space and we remove this number. Right? Please respond.
Yes, sir.
And this should be our 4 and 4 bits. 0, 0, 0, 1, 0, 1, 0, and an empty space. Now There is a problem. We cannot insert zeros in here in this algorithm. If this is a q register, this is q0 number bit, right? Please respond. This is q0, right?
Yes, sir.
This is q0, this is q1, this is q2, this is q3. So in this way, this is q0. And in this algorithm, if we look at, we assign some values based on a condition on q0. So actually, after this shift left AQ, we are going to keep this space empty. Okay, please respond. Is it okay? Clear?
जी सर.
Okay, now we are going to go to the next step. What is the next step after the shift left? A is equal to A minus M. Now A is equal to A minus M, but we are going to perform this as A is equal to A plus minus M. Okay, A is equal to A plus minus M. So this is A. From the last step we have, this is A, and this is minus M as always, minus M. If we add these two numbers, we get this number in binary, right? Please respond.
Yes, sir.
1 plus 13 is equal to 14. Now, where we are, we have performed A is equal to A minus M. Now there is that condition. If A less than 0, then do something. If not, then do something else. Now question is how we are going to find it if A is less than 0. Okay, so A less than 0, it means A has to be negative. If A is negative, do this. If A is positive, do this, right? Please respond.
Yes, sir.
So how we are going to know if a binary number is positive or negative? Looking at the sign bit of any number, we can say if any number is positive or negative. Now this is final A after the A minus M operation. After the A is equal to A minus M operation, this is the final A we got. And what is the sign bit? The leftmost bit or most significant bit is the sign bit. So if that sign bit is 0, number is positive or greater than 0. If that sign bit is 1, if that sign bit is 1, then the number is negative or less than 0. So looking at the sign bit, can you please tell me if this number is less than 0 or greater than 0?
Less than 0, sir.
Less than 0. So less than 0 condition is true. So it will go to yes and it will assign 0 on Q0. Remember, this is the 0. So let me drag this in here. Actually, I'm going to do this in here. This will be the 0. I'm going to denote this 0 in red color so that you can see. This 0 is been in here in Q0 after this operation A less than 0. We have assigned 0 in Q0, right? Please respond. We have assigned 0 in Q0.
Yes, sir.
Okay, now we have assigned 0 in Q0. Now we have to do one more thing because this is a yes, and for yes, there is one more operation. A is equal to A plus M. A is equal to A plus M. Now, if I do this operation, A is equal to A plus M. Remember, A is equal to A plus M. Now we are going to do this operation. A is equal to A plus M. So, let me write it down in here. Now A is this number. Sorry. A is this number, the latest one, and M is this number, this one. If we add these two numbers, what we are going to get?
Sir, ওটা minus m now.
Hmm, what?
Sir, ওটা
Okay,
minus
okay.
m now.
So somehow I have used minus M. I should use M in here, right? Minus M. 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 Min m in here. Actually, they are adding this in here. Okay, let me just write it back to what was in here. So this is the value. So actually, they are doing this operation in here. A is equal to a minus m. Maybe after this 0, they are just copying this value in here and writing this in here. After a minus m and checking if a is less than 0, which we found as yes. So this is the final value. Okay, before this a is equal to a plus m, this is the final value. This is a, sorry, this should be our a. I'm getting it again wrong. Remember, always we have to use the latest a, and this is our q. After assigning 0 in q0 as a less than 0 is yes, we have used q0 as 0. After q0 is 0, this is our result. A has become this one. After a minus m, after checking the condition, q has become this one. So now we have to do a is equal to a plus m, and for that this is a, latest a, this is m, from here 3, okay, this is m, and if we add these two numbers, there is that carry. See, this is actually 14, this is 3. So this will be 17. In 17, we cannot write it in 4 bits. We have to write down 17 in 5 bits. So this is the carry in here. And what we have to do, we have to ignore every carries in here. That is the condition. In multiplication, we used to take the carries when shifting left or right. Now we are going to ignore all the carries. So we have to ignore this carry. If we ignore this carry, this will be our latest A. So I'm going to copy this one. Let me show you. I'm going to copy this A onto here. This is A, and Q will not change. Q will remain. Q will remain. So is it clear up to now? Please respond in the step 1, because we have concluded the step 1 in here. Let me show you what we have done. These are the initial values of a, q, m, and minus m. After that, we shift left a, q. We don't know after the shift left what will be this value. When we performed a is equal to a minus m, this is latest a in here for us. Then we check the sign bit to get this result if a is less than 0 or not. Sign bit is 1, so a is less than 0 is yes. For that, we have assigned 0 in q0, this 0. So I better keep these as empty in here. So this is 0 in here. After q0 is equal to 0. Okay, so in here the operation was actually q0 is equal to 0. So this was the operation done in here. q0 is equal to 0. Then what we did actually, we have performed a is equal to a plus m. And after this, a becomes this value, and q remains 0, 1, 0, 0. Okay, now what I'm going to let you know is, if we add some value and subtract from it. For example, if this is the operation a minus m plus m, it will be equal to a, right? Please respond.
Yes, sir.
If a minus m, then we add a plus m with it. Like in here, we are performing a is equal to a minus m. We are subtracting m from a. Then again in here, we are adding m in that. So we are going to get back the original initial a after this, all this operation, right? Please respond. Look at this. In step 1, a was this. And after all the operation, a is similar. So our calculations are correct. So is it clear? Please respond.
স্যার এটা একটা একবার বুঝে দিবেন?
If we do this operation a minus m plus m, it will become a, right?
জি স্যার।
Like if we subtract m from a, then again if we add m in a, we are going to get a back. This was our A. We have subtracted M from it. Then we have added M with it. Now we are getting that A back again. 0.01. Is it
Yes,
clear?
sir. Okay, sir.
So in using this formula, we can actually check if this A is equal to this one, then our middle calculations are correct. If these two values are different, you will be able to know you might have made some mistakes in here. Right? Please respond. Is it clear?
Yes, sir.
Okay, so I'm going to go to the step 2. In step 2, we are going to come back here. How many steps we are going to cover? The number of dividend bits in here in the initial stage. And how much it is? It is 4. So if Q is 4 bits, then we are going to complete the result in 4 steps. So in step 2, we have to shift left AQ again. So we have to use the last AQ. Right? We have to use the last AQ. This is the last AQ. So I'm going to use this in here. This is the last AQ. If I shift left, I'm going to delete this number left side at 0, and there will be that question mark. What will be the value in here, right? Please respond. This will be the question in here, that what will be the value in here, right? Please respond.
Yes, sir.
So we do not know what will be Q0 after the shift left. So we are going to perform A is equal to A minus M. A is equal to A minus M. This is our A. This is our minus M from here. Minus M 1101. This is our minus M. So we are going to add this two number. 2 plus 13 is equal to 15. So we are going to store A as 15. A as 15. We yet don't know what will be this bit. Yet don't know this. Right? We yet don't know this. Now what we have to see, the sign bit of A. Sign bit. This one. This sign bit. And what is that bit? 1, right? Please respond. Are you hearing me loud and clear? Hello.
Ji, sir.
What is the sign bit in here? 1, right? Please respond.
Ji, sir.
If that is 1, then A less than 0 is 2. It is yes. Then again we are going to assign 0 in Q0, then perform A is equal to A plus M. So we are going to assign 0 in here, 0 in here, and we are going to perform A is equal to A plus M. Now this is A, this is A, this was M, 3, and if we add 3 with 15, it will become 18. So in 18, we have to ignore the carry. We have to ignore the carry. We are going to copy this one in here and this one in here. So this is our new look A and Q after the step 2. Is it clear up to now? Please respond. Is it clear?
Ji, sir.
Okay, now we are going to step 3. In step 3, what we are going to do, we are going to use shift left again on this number. So if we shift left again, we are going to delete this number in here. We are going to create an empty space in here. We do not know what will be the output in here. So again, using the method algorithm in here, we are going to do A is equal to A minus M. So if we try to do A is equal to A minus M, this is our current A. Remember, this is our current A. This is minus M. If we add these two, we are going to get 13 plus 5, which is equal to 18. Again, we are going to ignore the carry again. So if we ignore the carry, this is our A. We are going to copy this in here, and this should be like this. Now we have to check the sign bit of this A. And what is the sign bit of this A?
0.
If that is 0, sign bit is 0, then number is positive. If the number is positive or greater than 0, so it is no, right? A less than
Yes,
0 is no. So we are going to only assign 1 in Q0 and do nothing else. So we don't have to do A is equal to A plus M in here if that is a no. We only have to assign 1. So what we have to do, we have to assign 1 in here, this one. And for A is equal to A minus M, we have nothing in here. Why? Because we have this sign bit as 0. For that 0, A is less than 0 is no. It is positive number. So Q0 is equal to 1 and we don't have to do A is equal to A minus M. So this is our new A and this is our new Q. In step 4, we have to shift left this one again. Let me copy this one in here. We have to shift left this again in step 4. To do that, we are going to remove this left sided value, add a empty space in here. This is our new A and Q. So after shift left, what we need to do, A is equal to A minus M. So A is equal to A minus M. This is our A. This is our M. Sorry, minus M. If we add these two numbers, 4 plus 13 is 17. We are going to ignore that carry again. Whenever there is any carry, we are going to ignore that carry. Okay. So this is our new A. So if we keep this A in here and assume this as the empty space, we have to check the sign bit again. So looking at the sign bit 0, what will be this condition? No or yes?
Yes, sir.
Look at again. Sign bit is 0. If sign bit is 0, the number is positive.
आंसर
So
नो
in
पे जाके
sign in here the sign bit is 0. Okay, we have done the step 3. We are here actually. The sign bit is 0. The number is positive. A less than 0 is no. So it will only be Q0 is equal to 1. So it will be 1 in here and we need not to do any A is equal to A plus M, right? In here only Q0 is equal to 1. So we are going to skip that part. There is no requirement of this part. So this is our final A, which is 1, and this is our final Q, which is 3. So 1 and 3 in here as A and Q. So A and Q is 1 and 3. A and Q is 1 and 3. So everything is correct. So is it clear? Please respond.
Yes, sir.
Okay. Let me give this everything in the chat box one by one. Do not write anything in the chat box in between. This is up to step 2. And this is step 1 and step 2 nothing is gone. Okay. AQ0. After that I have to send everything. In step 2, where is that? Okay, let me checking here how much sent. In step 2, shift left, AQ, ignore any carry. After that we have to send. In step 2, ignore any carry. After that we have to send this again. Please do use this perfectly. I am going to send this. So this is the AQ. After that, ignore this one, this line only. And now step 3 only. And this is step 4. Okay, step 4. It will be up to this. Okay, so solutions are given in the chat box. Do take a look at this solution and let me know if there is still any confusion. Let me share the slide on with you. So look at the algorithm and look at the solution. Take some time, take 5 to 6 minutes to go through this problem or even more in case you need. Then I'm going to give you a task based on that. Then we are going to decide the syllabus and schedule for class test to
স্যার ওই a মাইনাস m প্লাস m ইকুয়াল টু a এটা কি দেখান লাগবে কোথাও?
a minus. No, 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 no. That is for your understanding that you can check if there is a minus m then plus and you can check if both the a's are same so that you can check your calculations are correct.
বাট সেটা স্যার অ্যান্সারে লেখা লাগবে না তো কোথাও?
No, 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 no need to write that.
আপনি লিখে দিয়েছেন তো তাই বললাম।
Okay, okay. That is for your understanding only. You need not to write this.
স্যার এখানে অ্যালগরিদমে কাউন্ট মাইনাস 1 দেওয়া আছে, এটা কোনো কাজ নাই।
No, no. Actually, we are counting. The n is the number of bit of dividend. Dividend is 4 bits. So if we decrease this, counter will be zero. Count variable will be zero after 4 steps, right? Click this one.
স্যার বুঝি না আরেকবার।
n
স্যার
in
কয়বার ভাগ করতেছি ওইটা কাউন্ট করতেছি কি?
no, 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 no. In count, you can see in the algorithm. In count, they have assigned the value of n, right?
ইয়েস স্যার।
Okay. So by doing that, they are actually assigning the value of number of bits present in dividend. So in our algorithm, dividend was of only 4 bits. So n will be 4 in the counter initially. And we are decreasing counter each time. We are decreasing the counter each time as count is equal to count minus 1. So after the first step, it will be 3, second step, it will be 2, third step, it will be 1. And after the fourth step, it will become 0. So look at the last, and if count becomes 0, yes, we go to end. Is it clear how count is working?
জি স্যার।
Okay, okay, okay. So do look at the problem. After 5 minutes, I'm going to give you another problem to practice for today's class. After that, we are going to decide on the syllabus of CT2 and the schedule date. Okay, I guess enough time given to see that I should give a task to you. Okay, task given in the chat box. You have to find the answer. Do find the answer quickly so that you can actually discuss discuss about the city two syllabus and it. Okay, I have given the task in here. At least if one of you find the solution, I'm going to discuss about that first.
স্যার যদি এ মাইনাস এম এর ক্ষেত্রে 5 বিটের সংখ্যা হয় তো সেক্ষেত্রে কি করব?
Can you please repeat your question again?
স্যার
When it is 5
এ
bit,
মাইনাস স্যার এ মাইনাস এম মানে এ প্লাস মাইনাস এম এই
doesn't
ক্ষেত্রে
matter.
যদি স্যার
We are all going to ignore the carries. The if there is 8 carries or 4, doesn't even matter. Ignore all of them.
স্যার সেক্ষেত্রে স্যার সাইন বিটটা কোনটা হবে? 1 না পরে জিরোটা? স্যার পরে জিরোটা না?
After ignoring the carry, the 4 bit that remains, you are going to find the sign bit from that. Okay.
ওকে স্যার।
Do please find the answers quickly so that we can discuss about the last test 2 topic. I think division is not that hard. We should find the results easily. It is just a bit long process and nothing. Rakibul Islam, you want to say something? You have raised your hand. Muhammad Rakibul Islam Soji, you want to say something? Maybe mistake.
স্যার সলভ তো করলাম বাট এটা লিখবো কিভাবে এটা বুঝতেছি না মানে চ্যাট বক্সে।
Write your answer only if you have the solution.
স্যার ফাইনাল অ্যান্সার লিখবো শুধু এ আর কিউ?
Yes, only the value of A and Q after the last step. Your answer is correct. So I guess one of you have find the solution. So I'm going to discuss about the class test 2 syllabus first, then the schedule. Okay. So better if concentrate in here. So others can keep trying to find the solution, and do please give your valuable opinion for the syllabus and the date as well. Okay. So I'm going to take class test 2 now. Uh, I want to know what you guys want about the syllabus. Okay. I'm going to give you two options. And from those two options, you are going to select a topic. Actually, three options could work for me. Okay, I give you two options. Okay, third one could have been a bit difficult for you. So I'm going to give you two options for the syllabus. One option is we are going to give CT2 on C code to MIPS conversion and machine code conversion from MIPS to machine on this topic. Or the second option is we are going to give class test 2 on only multiplication and division.
Sir, I think multiplication and division
No,
is
whatever you think, keep it to yourself. Just vote in the chat box. I'm going to give you that option. Option A is actually C code 2. I'm going to write it down in the chat box. C code 2 me and me to machine. Option B is section and division. So you guys please vote for A or B, then I'm going to decide the topic.
স্যার একজন ছাড়া সবাই বি।
All of you have voted. I can see 42 students in the class, but very few votes. Okay. Because there, I guess there is many more students are yet to vote because they will arrive late and they will say we want another topic. Why that topic is being chosen? So I guess I'm going to wait for another 2 more minutes.
স্যার 27 জন বি লিখেছে আর কি।
Already 27 B, and how many A's?
29 জনের মধ্যে স্যার 28 জন বি আর একজন হচ্ছে এ।
Okay, so 28, and how many students we have in our class? Let me check. We have 43. So 28B is enough for me to decide that it is topic B. So yes, for CD2, for class test 2, the topic for CD2, let me write it down. Multiplication and division. Okay. So topic is selected, and you guys know for multiplication there is 2 algorithm, and for division 1. So there is these 3 algorithms included, and everything along with that, like the hardware diagram, the algorithm or flowchart. Okay, the theoretical analysis we have seen for the multiplications. Okay, so everything is included of these topics: multiplication and division. Okay, normal multiplication, optimized, and division. So topic for C2 is multiplication and division. Now we want to decide the date. We have a class on this very Wednesday at 11th of August, and then we have another class on 18th of August, because there will be no class on 15th of August because of the makeup. We are actually having this class on this 9th of August. Okay, so there are actually 2 more classes left. 2 more classes left before the midterm exam. And if you want to give this class test on 18th, there will be no more days to review it for me. Okay, review the whole syllabus. So I want to take the class test on 11. Okay, as this topic you have as the topic you have chosen, to me it is easier compared to
সিটি নেন, মানে আমরা রিভিউটা একটু আগে করে রাখি বা সিটির পরেও একটু করলাম, কারণ সিটি দিতে তো আমাদের পুরো টাইম লাগে না ক্লাসে।
the topic you have chosen, you guys have chosen for CD2. I think you need not much preparation for that. I guess one day is enough in case you don't have too many cities on the upcoming Wednesday. You can do that, because if you do not give that, if you give that city on Wednesday 18th of August, then you are going to know about your mistakes only on 18th of August. Okay, so you guys decide. I don't have any problem taking it on 18th. You guys say whether you want it at 11th or 18th, because we have only 2 days of classes, not more than that. Midterm week is from 21 to 28th of August. So last class is on 18th of August. So you want review on 11th and CT on 18th, or what? Let me know.
Sir, CT on 18th.
স্যার
city
18 এই দিয়ে স্যার কালকে পরশুদিন অনেকগুলো সিটি দিয়ে দিয়েছে।
okay. Okay, so next class, 11th of August will be for the whole syllabus review, not only for CT2, whole syllabus review. Okay, 11th of August, and 18th of August will 18. Okay, few of them wrote it for 18 as well. So 18th of August is the date. So CT2 topic and date is settled. Okay, date is 18th August. So date and schedule fixed. So let your friends know about this in the Facebook or Messenger group you guys have. So there is no confusion about that. Okay, so I'm going to stop the recording now. There's no need for that.